So this is our last data review for that big polynomials test. And why did I have you graph negative x squared? Just to remind you that you don't have to have a super complicated graph to be a polynomial. And I knew you would know what the maximum point was. And we'd need that to be able to ask you what's the increasing and decreasing interval. You always just put a parenthesis and a comma. Would you please tell me what the increasing and decreasing intervals are? All right, Carlos, it's increasing from negative infinity, and that's because of this negative infinity, because these are x values. And that spot right there is 0, 0. So use the x value of it, and that's to 0. And then decreasing in this yellow zone, and Carlos, can you finish it off? And why is it infinity when it's going straight down? Because it's the x value. It's over here. All right. If you thought negative infinity, I get it, but you're wrong. It's x value. All right. So here's another one. It's a little tougher. You do not need to copy this picture. You just need to answer for me. What's the decreasing interval if this is negative 2, 3, and that is 1, 2? What's the decreasing interval? All right. Please compare that with the kid I always pair you with. In your case, just check with the guy behind you. X values, negative 2, 1. That's the x values, right? All right. And now, would you please do the 2 increasing intervals? And I'm going to put an arrow here just to make this really clear. That's an arrow there and an arrow there. They go forever. Now what's the increasing intervals? There's 2 of them. You should have said negative infinity to negative 2. And then 1 to infinity. You guys get those right? Okay, good. I feel like you're good on that stuff. Now, there was a whole sheet of 20 of those yesterday. Little things like that. Like, do you remember what the lead coefficient is? Do you remember what the lead term is? Do you know how many terms there are, etc.? Those 20 things, there were a few kids that had like 15 out of 20. That means you got 5 wrong. And that was with a partner. You got to admit, if you had 5 wrong with a partner, you might have had like 6 or 7 wrong, really, without a partner. So my point is I'm going to hand that back to you, and you should use that to study tonight. So I had lots of kids ask me, can I throw it away? Not if you had any wrong. If you had a perfect paper, sure, throw it away. You have nothing to study. Or if you had one wrong and you know what it was, fine, throw it away. But if I see you think throwing that thing away, it ought to be because you pretty much aced it. There'll be a few of you that did. All right. So we're not going to talk about all those easy things today that were on that sheet. That'll take too long. Instead, I'm going to walk you through all the different kinds of factoring I can think of. Would you please factor this? Now, I did not say to solve it. I said to factor it. Factor it. Check with the kid next to you, see if you got the same thing. X plus 2, X minus 2. Raise your hand if you had that one right. Okay, awesome. Are those answers that you would get real? Yes. So they can be x-intercepts, true or false? True. All right, good. And if you actually graphed this, just think about it. It's a parabola shifted down 4. And it would have it would hit like here and here, and what are those? Those are 2 and negative 2. It makes sense, right? Okay. All right, so now, obviously there's way more complicated factoring than that on the test. 2x squared plus 6x minus 8. Factor that one. So there's 2 kinds of kids. The kind who noticed that there's a 2 in everything, and the kind that didn't. How many of you noticed that there was a 2 in everything and got it factored out? Awesome. That's huge. You got to look for that every time. All right, so then it's x squared plus 3x minus 4. And then, again, there's 2 kinds of kids. Kids that were like, yay, I just factored it. And the kids that finished factoring. X and x, that's a negative, must be a plus and a minus. And then, I hope you've done enough of these by now that this is like second nature. All right, so then that's got to be 4 and that's got to be 1. How many answers do I have? 2. Now, some kids think, but there's a number out there. That's not a factor. It doesn't have an, no, I'm sorry, that is a factor, but it doesn't have an x in it. So that one would have an answer and that one would have an answer, but there's no x in this. You can't make this equal 0, can you? Because there's no x. All right, so then there's 2 answers. Does that make sense with what degree this is? Yes, it's degree 2, so always look for that. All right, next one. Write this one down, x to the third plus 3x squared plus 4x plus 12. This is called divide and conquer, or factor by grouping. I will try to leave time today to ask questions. I hope you are willing to ask the kid next to you, though, because there's going to be a fair amount of questions today. And the kid next to you can probably help you with, half the questions you might have. So don't be shy about asking the kid next to you when there's a line up in front. All right, most kids can get to here. Mr. Breen, those 2, they're the GCF. So what do I do?
Bring them down and just put them together.
And what's the final answer?
X plus 3 and then x squared plus 4.
Good. Now, did you even check to see if you could factor that? You gotta always look. Now, this one does not factor, but at least did you look at it and see, I wonder if I can factor that. All right, so always watch for those because sometimes it factors further. Now, this one has real and imaginary answers. Would you please tell me what the reals are and the imaginary answers? All right, for the real answer, you can just say x equals -3. And if it had asked for an x-intercept, then sure, x-intercepts have y equals 0, and you could have said -3, 0. What's the difference? If they want an x-intercept, that's how you write an x-intercept. If they want just the solution, you can write it that way. or the root, or the 0. This is solution, roots, or zeros are written that way. All right, now how about the imaginaries? I hope you knew that this was x squared plus 4 equals 0. And I've had a ton of kids who try to do it without the equals 0, and then they screw it up. Because then they're like, oh, I'm going to square root, and then they get square root of 4 is 2, and then they think the answer is just 2. It's not. Because if you actually set it equal to 0, you'll do this, and you'll go x squared equals negative 4, and then you'll realize you're square rooting a negative. Final answer, absolute value is 2i, and then splits. X equals 2i, copy it exactly, and the negative goes right there. 2i and negative 2i. Raise your hand if you had that one right. Okay, awesome. You should be good at that. We had it on several tests now. All right. So the next kind that you have to be able to factor. 4x to the 4th plus 8x squared. And now give me just a second because I goofed this up last hour. Minus 12. Pause for a second while you factor. All you have to do is factor. You don't have to solve it. Just factor it. But factor it all the way. All right, once again, there's kids who notice the GCF and kids who don't. There's a 4 in everything. You needed to get that out. If you didn't, you'd get it wrong if you don't have a 4 in the front of your answer at the end. I'm sure most of you noticed that. Now, Cooper, I always start by going x and x. In this case, is that enough to make x to the 4th? You need x squared and x squared. Good. And is it plus or minus, and is it minus minus? Plus and a minus. And then, what did you figure out it was? Is it plus 3 and minus 1? All right, good. But wrong. It's wrong. I know a lot of you would have put this, and I'd had to mark it wrong. Nobody in this whole room even sees it? Ah, there we go. Jonah.
You can factor the x squared minus 1.
Yes. And you have to factor it all the way. Everybody finish that thing. And I swear half the class would have got that wrong right now. You got to look. If it's got a minus and it's got a perfect square, and 1 is a perfect square, just as much as if there was a 4 there or a 16 there, that 1 is a perfect square because 1 times 1 is 1. So x plus 1, x minus 1. Did you learn your lesson right there? Because then you won't have to make that mistake in the future. All right, good. So how many answers do we have? Parker, look close. How many answers will we have for this? Yeah, and you could know that just by looking at that. There's got to be 4. 1, 2, and a lot of people are like 3 and 4. No. The 4 doesn't have an answer. But this has a double answer. And I've done enough of these now where I get used to this and I'm like, I'd set it equal to 0, I'd subtract 3, I'd square root a negative 3, so I know that's imaginary answers. Do you remember me saying that if there are imaginary answers, there's always 2? If you ever find yourself writing down the imaginary answers and you're only giving 1, you're screwing up. There's always 2. If there's imaginaries, there's 2. It's because of the absolute value in this. I'm going to just show you real quick. X squared equals negative 3, square root, absolute value. You will have 2 answers. I root 3, because the negative was underneath the root. And now I'd split it and I get 2 answers. Okay, good enough. Next one. This is where we start doing, what do you call that again? Synthetic, thank you. X to the 4th minus 6x to the 3rd plus 6x squared minus 6x plus 5. But wait, Mr. Server, you didn't tell us what number to put in the little box. Now this has 1, -6, 6, -6, and 5. Did you even look and see if there was missing terms? X to the fourth, X to the third, X to the second, X to the 1. There were no missing terms, but I'm warning you, later there will be missing terms, like in your homework. They'll like start with X to the 5th, and they'll skip all the way to X to the 2nd. If they do that, you have to have zeros to hold those places. So watch out for that. All right, now this is like a whole separate question. Can you tell me what 4 possible numbers could be in here? Who remembers that little formula I made up to prevent like a 3-paragraph definition of the rational root theorem? Yes? F con over F co. Very good. And that stands for factors of the constant over factors of the coefficient. Quinn, what are the factors of the constant? Here's the constant. And? Yes, you're good so far. Plus and minus 5, but there's a one more factor that a lot of people forget. 5 times what? 1. Got to include that one. So there are 4 answers, plus and minus 5 and plus and minus 1. Those are the 4 things that could possibly work. So, try them. And as soon as you find one with a remainder of 0, you got it, and you're going to be able to factor it. You won't have a partner on the test. You'll have to try them all yourself. What's really frustrating sometimes is that you make one little negative mistake in it, and you think it's not working, but one of them will work, I promise, on this one. Who can verify they found one that worked?
1.
All right. And if you've gotten stuck so far, try 1. Now, somebody might be like, but wait, I did this other number. You can have 2 things that work. That means they're both going to be factors at the end. They're both going to be roots at the end. If you found 2 different numbers, cool. Use either one. But I'm verifying that 1 works. Drop it like it's hot, multiply, add, multiply, add, multiply, add, multiply. Uh-oh, that's a negative 5, sorry. Multiply and add, and I get a 0 remainder, cool. But can you actually interpret that into what factors it is? Like bring in the x's now? This was x minus 1, for instance. And I hope you get this part. That's the x's, that's the x squareds, that's the x to the thirds. The thing I think I'm going to mark wrong the most is kids won't finish factoring. Like this can be factored again. X minus 1 can't be factored anymore, but this part can be. Now you have 2 choices. You can do synthetic again if you want to. We know, since it has a 5 at the end, that the same 4 numbers could work. And we already used 1, and it worked. And now 5, somebody else said 5 works. So I could use synthetic right here and use a 5. You know, do that thing. You could do that. Or you could factor by grouping. I say whatever's easier, do that. So I like factor by grouping better. Maybe you like the other way better. X squared, x minus 5. And this part, 1 factors out x minus 5. It's kind of tricky. Those 2 are the common factor now. Just copying the x minus 1 down. Now the common factor here is x minus 5. And then what's left? X squared plus 1. Did you at least look at this and see, I wonder if I could factor that? You can't, but did you at least look at it? What would have made it factor? If this had been negative, it would have factored. And if you're like, but I think it does factor. Some kids are like positive that it factors. Problem is that x times x makes x squared, but they think this is the answer, and it's not, because that would make negative 1. See, that's why with negative 1 it would have worked. This does not factor. All right, cool. All right. There's a gotcha on this one. Okay. Here's hoping that you noticed that they all have an x squared in them. I know some of you are like, but I factored by grouping. Great. Does your answer have an x squared at the front of it? Otherwise, you didn't factor it right. They all have an x squared. So then this is x to the third plus 5x. And am I taking out an x squared? This is a squared. And then plus x plus 5. And then, I know some of you think, but I did it a different way. Okay. Did you have an x squared factored out to the front? Because if you didn't get it right. This and this, divide and conquer, both have an x squared in them. X plus 5. That has a 1 in it. X plus 5. Those two are the common factor now. X squared just comes straight down. Then the x plus 5. The order really doesn't matter. And then the x squared plus 1. Who got it all the way to there? Not many people. Do you see what you did wrong? I betcha most of you just didn't notice there was an x squared and everything. How many of you didn't notice that? Raise your hand. Be honest. All right. Thank you for being honest. Do you get now that there was an x squared and everything? Then it's not that hard. All right. Okay, this next one, write this down. X to the third minus 2x squared minus 9 has a built-in gotcha. Does anybody see it? If I was going to say, hey, test this, test 1 and see if 1 would work. What's the gotcha? Caleb?
You're missing the x.
Yes. See, this has x to the thirds, x to the seconds, but where are the x to the firsts? So if you do this, you go 1 for this, negative 2 for that. And I would say it this way. How many x to the first do you have? 0x to the firsts. And then the negative 9. Process that. Do you get why I put a 0 there? because it's like there's 0x to the firsts, oh, not to the second, to the firsts squeezed in there. A lot of people didn't notice that on the Schoology quiz. There was one like that where they just didn't have any x's. All right, Dixon, tell me how to do the drop it like it's hot, and then what do I do next?
1 times 1.
And then I add them as -1, and I multiply them as -1, and I add them as -1, and I multiply them and it's -1, and I, oh crap. If I had said, is 1 a factor, no, not a factor, is 1 a solution? What would you say? No, because the remainder is -10. Yes,
If there's no constant, when you add a 0 for the constant as well?
that's a good question. No, if there's no constant, that means there was an x to factor out of everything. See what I mean? If there is no constant, that's a good, important gotcha kind of moment. But that means that I all have an x that needs to be factored out. Okay. All right. So now, this one just didn't work. But I will tell you that this one will work if I tell you the right number. I told you to try 1. 1 didn't work. But I'm going to tell you the number in a weird way that you have to be able to interpret it. Is x minus 3 a factor? So here's the whole question. Did you realize you needed to put a 3 here? Because see, the factor always has the opposite of this number. All right. And then, did you remember the placeholder? 1, -2. There's 0x to the firsts in here. 0, -9. Pretty sure that works. Can I have somebody double check it?
Yeah,
It's been verified. Make sure you work it out for yourself, though. Because there's a remainder 0, it worked. Now, what if the question was, is it a factor? What's the answer? Yes. This was a factor. And if you just write the answer, you'll see x minus 3. It's right there. It's a factor. Steichen, what's the rest of the answer? What do I put here and here?
It's x squared, and then after the other one is x.
Yep. Did you even look to see if that would factor again? If you looked, you win. It doesn't factor again. But if you didn't even check, that's going to be the most common mistake on the test is you factor it partway and you forget to factor it all the way. All right. Next thing. What is a list of all the possible factors? And I'll tell you there's at least 6. There might be more. And I shouldn't have said factor. All possible roots. All possible zeros. You know the number you could put in a little box? List out all of them like this. Don't try to do it with a plus minus. list out all of the answers. And I told you there's at least 6. Hadley, what's that little formula you gotta know for this? F. Very good. What are the factors of the constant?
-5.
Plus and minus 5. Would you agree with that?
And then 2.
2 goes into 5?
1.
There's more factors of the constant. There you go, and 1. I'm just going to put it like that. Plus and minus 5 and plus and minus 1. Okay. Now, I think you were saying 2, and I think you were giving me the factors of the coefficient, right?
Yeah.
So then that's plus and minus 2. Is there any other factors of the coefficient?
1.
Yeah. If you leave it like this, I will cry a little bit and mark it wrong. That's not a list of at least 6. I said there was at least 6. That might means there might be 8. Because you got to know you got to take this 5 and divide it by 2. So 5 over 2 is one of your answers. And negative 5 over 2 is one of your answers. And then you take this 5 and divide it by 1, and that's just 5. And then negative 5. And now I'm going to take my 1 and divide it by 2, and I get 1/2. And then negative 1/2. Is there any more? Yes, there is. What's the last ones? Yeah, you take this and divide it by 1. And 1 divided by 1 is 1. And then, of course, negative 1. Look at that. There was 8 possible roots. Be honest. How many of you would have probably got that wrong? That's enough hands. We should try one more like that. 3x to the third plus 2x squared plus 1 plus 4. 1x, sorry. Give me all the possible roots. Carlos, what's that little formula for this thing? Fcon, Fco. What are the factors of the constant? Plus and minus 2, plus and minus 4, plus and minus 1. I agree with all of those. Tomas, factors of the coefficient?
Plus and minus 3, plus and minus 1.
Yes. Now I'll see if you can put them all together. You gotta divide everything by everything. All right, to add an extra level of concern on this one, because frankly, I know some of you are just kind of drifting, you're getting tired. You're gonna share this answer with the kid next to you to see if you've got all of them and if they've got all of them. There's a bunch. Take a second, talk to that kid next to you.
Negative 4/3. 2. Negative 4. 2/3. Negative 2. Negative 2. 1/3. Negative 4. Negative 4. 1/3.
Yeah. I think it's okay.
Just taking all that fraction. What? Yeah. Yeah. Like the 2 over 1 and I just used the 2.
Yeah, I guess.
there's nothing wrong with that, it's just.
Yeah, it's still sitting there too, so you gotta really-
12 possible answers. Did you guys get 12? All right. Cool. Whew. So many things to know. Now, one of the things that would be important would be to know, instead of me giving you a graph and saying, hey, what's the equation for that? We've done that a bunch of times. And I'm hoping you'd be able to pretty quick go y equals, oh, this one's going up on the right, so it would start with a positive, and then it'd be x plus 3, and it's bouncing there, so it's squared. And then this 4 means I'd have an x minus 4. Do you get how that would have worked? Does that all make sense? I've done that a bunch of times. What if I just gave you verbal or written clues, and I said, like, well, there's a double. You don't have to write this down, but you have to tell me the equation for it. Here's a double root at 3. There's a single root at 0. And there's another double root at -5. Oh, and by the way, the lead coefficient is -1. Can you write me the equation for that? Always just start with y equals. And after you've written the equation for it, sketch the graph of it. And that covers everything that I could think of. And the lead coefficient being -1, I hope you wrote a negative in front, and there is your equation for it. And now can you sketch the graph of what that would have looked like? Hint, there's a negative in front. That's where I would start. Okay, and then I know, since it's negative in front, it must be going down on the right. And I know my zeros are at 3 and 0 and -5. Adra, can you tell me what happens at the 3? Bounces. How about at the 0, Adra? Just goes through there. And how about at the -5? So therefore bounces again. There you go. You guys have that one right? All right. Cool. Now, you got a bunch of time to work. More than ever before. If you spend an extra half hour tonight just being absolutely sure, you might save yourself pain. Why? Because you're going to go into a long break period. At some point, you know, like on the lead up to the holidays, your parents are probably going to go and, I wonder how the kid's doing on break. And they're going to go check. And do you get if you have a bad grade on this test, we won't have had the cumulative test yet? So that grade is gonna ride in there all the way until like January 12th. Okay, so if you have a bad grade tomorrow, you're stuck with it for almost a month because of that break time. So be really smart. Spend the extra half hour tonight. Really going over the key really carefully. Okay? All right. So you got an answer key, you got homework, you got me to ask, you get the kid next to you to ask. If there's a line for me, please try talking to the kid next to you. But then if they can't help, come on up. That's all I got for you for today.